So in this video, we'll have two examples, a little bit more complicated than the previous ones, but it's the same process, exact same process. There's just more letters and numbers that are written out. So we're going to start with this one, 5 over the quantity x minus 3 plus x over the quantity x minus 3 times the quantity x plus 3. Do not multiply out the denominators. That will be moving backwards, okay? We have it in a form where we can see what the factors are. Remember, to make the denominators the same of both of these fractions means to make the denominators have the same factors. So in the first fraction, 5 over x minus 3, right, I'm missing this x plus 3 factor. So I need to multiply this one by x plus 3 over x plus 3. And then both fractions will have the same denominator, right? And then the second one I don't need to change because the denominator is already what it is on the left. X minus 3 times. Now you might be tempted to multiply this out, x minus 3 times x plus 3, because that's the difference of two squares formula, so it's x squared minus 9. But don't, just leave it factored, because we like the denominator factored so that at the end I can see if anything reduces. Okay? So now I need to multiply out the numerators, which is just this one, so because that's already just one term. So 5 times x, 5 times 3, right? And then I'll add the x to that. And keep the denominator the same. So this is what I get. 5 times the quantity x plus 3 plus plus x over the quantity x minus 3 times the quantity x plus 3. Now I need to multiply out that numerator, distribute the 5 across the x plus 3. Okay, now I need to combine like terms. So there's two x terms, a 5x over here and an x here. So I need to combine those. And so I get 6x plus 15 over x minus 3 times x plus 3. 6x plus 15 factors is a common factor of 3. So factor that out. So you get 3 times the quantity 2x plus 5. Because 6x over 3 is 2x, right? 6x over 3, we're factoring out a 3. So 6x over 3x is 2x, and 15 over 3 is 5. And then you notice that the numerator has two factors, 3 and the quantity 2x plus 5. The denominator has two factors, the quantity x minus 3 and the quantity x plus 3. So there's no common factor between the numerator and denominator, so we're done. These things, the answers can come out with several numbers and letters in them. That's totally normal. They don't always reduce. Okay, next example. Now in example 8, I factored the denominator for you, right? This, if I didn't factor this, it would have been x squared minus 9, and you would have had to have factored it yourself. Okay? So this one, I wrote them with 2 where you have to factor the denominators. The numerators are already factored here, so that's nice. So I just have to factor the denominators. And so these are both trinomials, so you have to use your method, whichever method you're using, for factoring trinomials. I just happened to look at them and see what the answers were, so I just wrote them down. But you can do this kind of off on the side on your paper and figure out how to factor x squared minus 5x plus 6, and then figure out how to factor x squared minus 2x minus 3. You can use the AC method, or you can use that so-called guess and check method, which doesn't really involve guessing. And then or you can use some other method that you've approved with me, okay? And the approval is just to make sure that you're doing something that works for all the trinomials and not just for some special ones or something. Make sure it's correct. Okay, so now now I've got the factors. I can see what all the factors are, and there's quite a few missing ones. Like these are very different denominators. They have in common an x minus 3, so that's cool. So we don't have to worry about the x minus 3. But the first denominator does not have an x plus 1. So I have to put that in there. So to put that in there, I have to multiply the denominator and the numerator by that. When I multiply the numerator by that, remember x minus 4 is a single factor of the numerator. So I will have to put parentheses around the x minus 4 if I'm going to multiply it by the binomial x plus 1. That's super important. People sometimes forget and leave that out. And write them down that way. Don't just say, I know what I mean in my head. Write it down with the parentheses. So I'm going to multiply by x plus 1 over x plus 1. Now the second factor is also missing something that the second denominator is missing something the first denominator has, which is the x minus 2, right? There's no x minus 2 in the second denominator, so I need to put one there. So I need to multiply the denominator by x minus 2 and the numerator by x minus 2. So I'll do that next. They start looking more intimidating, but you're just doing the same kind of things you do with actually just rational numbers, fractions of integers. We just have polynomial factors. Okay, so now both fractions have the exact same factors in the denominator and the same number of factors, 1 in this case, of each factor. So you've got one factor of x minus 3, one factor of x minus 2, and one factor of x plus 1. Over here you have one factor of x minus 3 on the second fraction, one factor of x minus 2, and one factor of x minus 1. It doesn't matter that they're written in a different order. Okay. So now I can add the numerators. So I add the numerators. Now you could multiply out the numerators while you're adding them if you're comfortable with that, but you know, this is our first time through one like this, so I wanted to write them out kind of step by step. So now what I need to do is multiply out the numerators. Why? There's two terms in the numerator now. There's the quantity x minus 4 times quantity x plus 1 term, and then there's the 2x times the quantity x minus 2 term. I want to have one term in the numerator because the denominator has one term. Remember, terms are things that are being added. So the denominator has one term. It's just a product of 3 factors, and so we want the numerator to just have one term, which means it's factored. Okay? So you want to multiply these out. So using distributive property, right? So you end up getting this. The x minus 4 times the x plus 1 gives me x squared minus 3x minus 4. And the 2x times x minus 2 gives me 4x squared minus 4x. No, I'm sorry, what am I talking about? 2x squared minus 4x, right? Then you need to combine like terms, so I have 2 different x terms, right? There's an x term there, and there's 2 different x squared terms. You have to combine those. There's 2 different x terms, you have to combine those. And then there's just the one constant term that you'll tag on the end. So I get 3x squared, right, minus 7x minus 4. The whole thing over the 3 factors, x minus 3, x minus 2, and x plus 1. Now, I want to try to factor the numerator to see if it has a factor of x minus 3, x minus 2, or x minus 1. If it doesn't, I don't really need to factor the numerator for this. Let me check real quick. 927 minus 21 minus 25. That doesn't work. A quick way to check this is to take zeros of the binomials in the denominator and plug them in to the numerator and see if you get a 0 out of it. because that'll tell you if they have a common factor. So, for example, here, I could take 3. That's a 0 of this polynomial, right? It's what makes it 0, 3. Well, if this reduces, that means that one of the, with this x minus 3, that means one of the factors here is x minus 3, so when you plug in 3, you'll get 0 because of the x minus 3. So I just tried plugging 3 in here, and I got 27 minus 21 minus 4. So 27 minus 25, which is not 0. So this is not a factor of this numerator. Here, the 0 of this little polynomial is 2. So if I plug 2 in here, do I get 0? 3 times 4 is 12, minus 14 minus 4. No, too much negative stuff. So x minus 2 is not a factor of the numerator. Here, the 0 of this is minus 1. If this is a common factor with the numerator, then the numerator also has to have a 0 of negative 1. So if I plug in negative 1, I should get 0. Okay, negative 1 squared is 1, times 3 is 3. Negative 1 times 7 is 7. So I've got 3 plus 7 is 10, minus 4 is 6. It's not 0. So this isn't a factor either. So now I don't have to worry about factoring this. Okay? In fact, I think this might not factor at all with integers. But it doesn't matter. So it does not factor. And that's how I could tell. It's a little trick. If the numerator and denominator have a common factor, then if you plug a 0 of the common factor in the denominator into the numerator, it should be a 0 of the numerator. So the denominator and numerator have the same zeros if that reduces. Okay. So put a box around it.